So, gentlemen, welcome to today's training. This is day 3 of our training, still on module 1. We have 3 modules. Module 1 is on water reticulation design, water supply, water distribution, whatever name you give it, is the same thing. Our module 2 is in stormwater and sewer design, generally called urban drainage. Next week or next week, we'll get to know about it. Then module 4 is on road and infrastructure design, right? And the first module will take the first 3 weeks. This is the 3rd week. So expectedly, we are going to end module 1 today. But then let's see how it goes and see whether I can. Or I can see what I can do. So I'm now saying this assignment, I said we should use a slope, assumption, a slope of 0.3, right? And I also say, what are the pipe sizes? So I now say, instead of not to waste time, can you quickly go to the chart box and put in the values you got? So I'll be mentioning the pipe sizes. You go to the chart box and then tell me the value you got. If I see conflicting value, then I'll draw my attention. So for industrial nuts, what is this pipe size? And for housing fortunately on the right, which is tank 1, industrial nuts is using tank 4. It's a decentralized design. It's a decentralized design because when we started, we got to know that the land is not flat and the elevation difference is more than 8 bars. Therefore, we go into what we call pressure zoning. Some people call it phases, no problem. But the real technical word is pressure zones. Pressure zones because everybody must not get water from the same elevation. Everybody must not get the water from the same source. Therefore, you need to zone them into appropriate riparian communities so that there will not be excessive pressure. We said that the base nominal pressure we expect in our pipe network is between 2 to 3 bars. But the upper limit is 8 bars. And we also say one of the reasons for this is because some of the pipings and the fittings and whatever you have in the market cannot take anything more than 8 bars. Only in recent time have we started seeing pipes that are 12 bars, 16 bars. But then, have you considered the connections too? Have you considered the tail end of those connections? So can they really take pressure more than 8 bars? The answer is emphatically no. So you must stick to that standard. You must make sure that 8 bars is not extending your system. And when that is being happened, then you need to introduce booster stations. You need to zonalize, put them to pressure zones, and then you need to decentralize the system. Yeah. You need to create separate tanks. You can still use the same source. You can also customize it to different source, different tanks, so that it will deliver water effectively, efficiently. Quality parameters will be met, quantity parameters will be met, and sustainability parameter must be met. Okay, so I go back to my question. I'm saying this so that I can have the answers. So can I have the answers on my chat box? So 250, you didn't indicate, Engineer Ngozi, 250, is it for which one? Is it for play? Open your mic. Everybody can open your mic. But
for industrial notes.
Industrial note, do we have a conflicting figure? Okay. So write industrial note 250 mm. HF, housing fortunately, you write the value. Then commercial east. If I do commercial east, I don't have to do commercial south. The same pipe size will take them. Yes. If I do swimming pool, I can use the value for swimming pool for housing fortunately. Housing fortunately is approximately 200. So I can use the value for 240, the pipe size for 240, and design it for 200. For that of housing at Agegenberg, the last on my right, I have to do that one. I don't have to do that one because it's almost between 709 and 320. So if you look at the design, at the end of the day, I'm expecting to see like 3 pipe sizes, except for industrial nuts. Others can be within 150, 200, you know, because their values are just not so dispersing. Then if you look at camping, I'm going to use a nominal pipe size for camping because that flow rate is so poor, so small. I mean, it's camping ground. Why is this poor? Because it's a camping ground. People don't, it's just it's a small camping ground. People just come once in a while. It's not like you have people residents there. So you can see. And you can also see why industrial north is very high. I mean, industry, you need use of water. It's massive. So you could begin to see why you need to do your population characterization. Let me use it again. You need to do, we did it in the first day. You said before you start your design, you must go to site, take your survey level, you then do site characterization. What is the land use? What is the highest number of floors I'm expecting here? What is the population equivalent by house? What is the appropriate safety factor I have to use? And by the time you start to do these things, then you'll be getting it right. Okay, so somebody say camping 75 mm. Yes, yeah, of course, that's nominal. But in the chart, you get something like 50. But I say it again, in water reticulation design, in general infrastructure design, it is better to overestimate than to underestimate. It's always better that if 1 meter, if 1 meter pipe is enough, if I provide 1.2, it is not bad. But it will be bad if I provide 0.8. That's the rule of thumb. Okay, so I'm not getting the feedback I need. Only 2 people are commenting. So I will leave it at that. Let's assume that we didn't have time, or maybe I didn't remind us to do this assignment. But like I said, try and do this assignment so that we can cross off some gray areas. Okay, so the second thing I want us to open now is the ABC design. The ABC design. Okay, and then open the branch system, which is what we stopped yesterday. So now the question is that I'm willing to share my screen with somebody. If somebody has his own screen on the laptop, I can give you permission to share your screen. So let me see what you have done. So now the question is, let's talk. I can pause the recording. So once again, the assignment says 30 BE per house, right? Then let's say we have over 100 houses. Don't worry, I understand. So each house is now 30 times 100 times 2, right? Right?
Yeah, that's correct.
Then divide by 86400.
Sorry, please. You said 2 suspended floors.
Yes. That 2 suspended floor comes in when we are doing which floor will you use as your reference. That's just what it means. You cannot have 30 people in a plot if it's not 2 suspended floor. So the issue of 2 suspended floor comes in when you are doing your pressure, your pressure losses. You consider that you started the person at the uppermost floor because that becomes your reference. So if you are, let's say you are trying to elevate your tank, you don't use the person at the ground floor now. You use the value of the level of the person at the second floor. That becomes your reference. So if I ask you the elevation of the place, you will not give me the elevation of the ground floor. You give me the elevation of the person at the last floor.
Good.
Times 2, 6,000. Divide A6400. Okay, so it's about 0.09. So this
0.069.
0.09.
0.069 liters per second.
0.07, sir. So 0.07 yes. Now. And we are talking about, let's say 100 houses times 0.07. What will it give you?
0.7.
No, it will give you 7 liters per seconds. So okay, the person saying 24. How did you get 24?
Because me at that station I got 7.738.
You are right. You are right. So station ST storage tank. How many people got something around 7? You know, engineering is approximation. 6.97. I don't care. But How many people got 7 at that point? How many people got for 30 per house and 100 houses in the estate, in the layout, sorry? Therefore, this is the value. The value is 0.07 liters per second. Right?
Yeah.
And 100 liters per capita per day per capita is our water demand. So how many people got that? Okay.
I've not worked on my own, but I'll hopefully do that.
Okay, so in that case, please, let's continue with our computer application. That means everybody, please, if you go back, try
No, sir, engineer.
and...
Engineer, I have a question.
Okay.
Yes, I have a question. You see,
Go
I
ahead.
got that 7.73 something liter per second, and then my pipe size was 150 diameter. That is one.
Perfect, sir.
But then,
Yes.
while walking through, there is this thing that comes up. You know, you asked us to use the slope of 0.1.
Yes.
So at node 13, which is the initial node, what I got was actually I reference to your this thing of saying the velocity as well should be considered, and it should not be less than 0.3. Oh no, sorry. Yeah, it should not be less than 0.3. It should be between 0.3 to 1.2. So I needed to increase my slope at that level. Then I increased it to 0.18. Is that okay? To have a minimum velocity of 0.3.
Yeah, that's okay.
That's okay, right?
Mm.
Okay, good. Then the next question is that now this slope of the thing, is it not supposed to be, what is the relationship of this slope with the topo of the site itself? Because
the slope is the difference in elevation over difference in horizontal distance. It means slope is slope. What it is what it is.
That's correct. Is what it is. So now the confusion is that you gave us the value. I was thinking, since we had the topo of the site, for example, and then it indicates the
it will complicate.
difference.
Why I did not use it is that it will be more tedious.
There's breaking transmission.
It will introduce another layer of problem.
Okay.
Hello? It will introduce another layer.
Okay,
the person is battling slope and is battling, but I just want to minimize it. So now let's go. Let's move to the writing now. Let's do the OT assignment now. Let's move it. So we open ABC design. If you have not done that, there's a Word document called ABC design. Are you there?
Yes.
Okay. So yesterday, to do the manual design, we treated this. I think everybody got it right? So let's go to that layout. So that layout, okay. So I think if you read all this, you understand it. We've explained all this. Okay. So let's start here now. Just scroll down. You see calculation of demand in each node. Why are we calculating the demand in each node? So that we can fill this sheet. If we did not fill this sheet to the first 4 columns, you must fill this first columns, right? Then you now use it to dimension your pipe size on site. Don't worry, I'll still give us some video support for all this training. The problem is whether you have time to go through them. So now, this is the ABC design. So now, for this one, we are assuming it is a 4-bedroom duplex that has 20 dwellers per person. As I'm doing this thing, I want you to be looking at this. This is what we are doing now. This layout. This is the size you have been given. Look at it. It looks small because it's just training, but it can look big. If you look big, all you need to do is just assign node to everywhere. So if you want, let it extend by, there are 100 buildings here. If you want, let it extend by 1,000 buildings. It doesn't make any difference. All I need to do is to number every node. And then I'll start from the bottom, the least node, like at the end nodes. And I'll start coming inside until I get to the start tank. You get the point? When I finish my value and I got those 4 values, I will now go back to the detail of the AutoCAD. I will now be assigning it. I won't write diameter, but I'll put a sign for diameter. I'll say Q theta equals 25 mm at slope 0.25. Then invert level here, invert level there. I'll give us a typical water infrastructure design. It's just for you to put in those values you got from those tables. That's why I expected many of us to go through those tables. I expected somebody to fill those tables. Therefore, what I will do after today's class, please, next week's class, I will insist that you do this assignment. Maybe you've not grasped it very well, I can understand. But today, you definitely have to grasp it. So I can fill those tables. By the time you fill those tables, if I look at the values, I will say, okay, you are right or you are wrong. Remember that our end goal is just to get the pipe size. Come on, that's all. Just to get the pipe size. But to get the pipe size, you must get the water demand, because it is the water demand that the pipe size need to convey. You got it? So now, so be looking at this. This is what we are designing. This is the design. And the value we are calculating now, this is the design. So this is the distributed network. This is how it will be drawn. And then this is how it will be computed. This is your calculation sheet. We are engineers. This is how your calculation sheet will look like. For every pipe design, this is how the calculation sheet is going to look like. Whether it's stormwater, is sewer, or is water, potable water, this is how it must look like. You must copy this. Okay. Now, let's now go how all these can be realized. Remember the 4 parameters you're looking for. The demand, which is in liter per seconds, the appropriate slope, the diameter, and that's all. The length has been given to us. So it's just these 3 now you need to fill. This one now is the H real. So the slope of each point, you put it here. You can see that this is slope, this is real. By the time you get this slope, sometimes you might need to go back and get the other slope, because you have made assumption. You didn't see 200 mm pipe.
Excuse me.
You used 250 mm pipe. Hello? Is that a question?
Excuse me, sir. Can you click this by your right side? Can you rotate this your table so that can you rotate this your table?
Rotate it from your end.
See the arrow by the right side. That arrow, turn it.
This one?
Okay, I've done my own already. So that I want to be seeing what you're doing exactly.
Thank you. Okay. So what I was saying in essence is that let's say we discussed it last week. The 4 parameters is 1, length, the Q, the slope, the diameter. To get the slope, this is storage tank 1. The slope is 310. Point 1, this elevation is 279. Therefore, the slope between point 1, storage tank, and point 1 is going to be this minus this divided by the length, which is 120. That was what the engineer is trying to say. This minus this divided by the length. Point 1 is 279. Point 2 is 272. Therefore, please, can I get it? To mute yourself. Learn to mute yourself is one of the disciplines we need to know about online things to distract the presenter. Now, point 1 is 279. Point 2 is 272. Therefore, the slope between point 1 and point 2 is going to be this minus this divided by 60. I don't need to do this thing again today. We have a computer class. Please try and do it. I gave us the whole 1 week to do it. So go back to ABC design. So each of those houses we are seeing in this screen is 20 persons. And we say we already assume that 100 liters per capita per day is enough for residential consumers. And we say we're going to use a P factor of 0.0. Therefore, each water demand per house, now we're assuming that the houses are the same prototype of 20 persons. That means if it is 4-bedroom duplex, it's 4-bedroom duplex or 1 floor or 2 floor, whatever. So it's going to be 20 times 100 times 2. It will give us this. You convert it to liters per day. You convert it to per seconds by dividing by 86400. 60 times 60 times 54. It will give you 0.0463
Engineer.
liters per seconds. Yes?
Hello, sir.
Please, you can talk.
Hello, sir.
So,
hello, sir.
I can hear you. Can you talk?
Oh, yes.
Okay, so we say we start from the list node, and that is node 13.
Hello, sir.
Here's the node 13. Here's the node 13. So I need to
yes, you asked us to use 30 person per house.
Yeah, we're doing a different one now.
Hello?
We're not doing the one you did. No, leave the assignment still stands.
Is it the assignment you are doing, or is this?
No, it's a new one. I'm deriving new parameters. I'm using new parameters.
Okay.
Yes, I'm using new parameters.
Okay, sir.
The assignment still stands. Yes. Okay, so now we're using 20 in this case now. So from node 13, so when I say node 13, you know where I am. This last node. So this last node, we calculate how many houses are here. Look at it. Count it. There are about 25 houses or thereabouts. So 23 houses, sorry. So we now say 23 multiplied by the value of one house. You don't need to start writing all this mathematics again. So we just pick up this value because they are all the same houses. And these are all the houses along section 6 to 13. So by that calculation, we get 1.065 liters per second. So that becomes the demand at that point. Now we say let us as this another assumption. We assume if you're assuming a slope of 0.5, the equivalent pipe size is 65, and we now check for velocity requirement. We say that the velocity must not be less than 0.3 and it must not be more than 3. So we now check whether velocity requirement is met. In this case, velocity requirement is met. So the pipe size at that section is 65. You as the designer, based on Engineer Uche's recommendation as a fellow of NSC and a very experienced person, current and everything, I say don't use anything less than 75 mm. So me, even to start with, if you go to the market, you're not going to see 65 mm. There's not like, okay, 65 mm is like 2.5 inches, yeah? But I can assure you, use 25 mm. So, but if you use 100, you are wasteful. You're a wasteful consultant. But if you use 50, then you're a failed, you're incompetent consultant. If you use 65, you're a conservative consultant. If you use 75, you are an optimal consultant. Optimal design. Okay. Now, you now move to node 6. In node 6, there are only 8 houses. If you look at it, you are going to be seeing 4 houses. But we said there are 4 undeveloped plots of land. You will include it because it must be for the future. So we now said 8 times 0.04, the same thing. It gave us 0.3. But we need to add this value to the original base demand we got from 13 because it is node 6 that will be feeding node 13. So that means at the point of node 6, the total water demand at that point is now 1.065 plus 0.37, making it 1.44. We move again. And if you do that, it will still maintain 65 mm. You see it? Even though the water demand is different, but one pipe size can still comfortably accommodate it. That is the reason why I said always use 75. You will discover that the next one will still accommodate it. So that you have fewer pipe sizes on your network. Yesterday, I was discussing with some structural engineers, and we are sharing our experiences. And I told them that when I'm doing slab design, for the bottom reinforcement, I always provide Y12. I don't do Y10. For the top bars, I can use Y10. And I said the reason for that is that I don't want the iron bender to get confused. So I let him not go and use Y10 along the main reinforcement and use Y12 along the secondary reinforcement. Some of them will tell you they are doing this work for 30 years, but you and I know that is wrong. So to avoid such scenario, when you do your pipe design, try to minimize the number of prototypes. I'm supervising one an estate now, an estate of more than 1,000 units. You won't believe it. Only 4 prototypes, and that's very cool. Just 4 prototypes. You don't need to have 50 prototypes, no, so that you have some level of uniformity and symmetrism. Okay, now we go to node 11. In node 11, we calculated 10 houses. So if you multiply 10 houses, you now get 0.46 liters per second. So that one is a straight jacket. Straight jacket. You don't even need to go to the pipe because the flow is less than 1. And we say, well, based on our chart, when the flow is less than 1, you use the volume fan. It's a standard rule of thumb. After that, I move to node 7. The base demand for node 7 is 6 houses. 6 times this give you 0.28. However, node 7 is made up of node 11, node 6, and itself. So itself is already 0.28 because there are 6 houses attached to node 7. And then node 6 and node 11 are also attached to him. Node 7 is somewhere here. Node 11 is here. So node 6 is here. There's node 13 here. So node 7 will now take 3 houses built, 3 houses unbuilt, which is 0.28. Add it to the node here, add it to the one here. Then you have its own value. And the pipe side, the water demand increased to 2.18, and the pipe size increased to 80 mm. Gentlemen, you see why I say 75 mm? 80 mm is not in Nigerian market. 75 mm will do the work. So you can see that from node 13 to node 7, I'm still using the same pipe size. And that is 3 inches pipe. Okay. I move to node 12. Where is node 12? See node 12 here. And how many houses? 1, 2, 3, 4, or whatever. Just count it, right? Good. So that becomes 65 mm. That one is another 3 jackets. You know how to do. I will do our slab design, civil engineers. Once we see that the span of the slab is no more than 30 square meters, we just use wide 20 men side. If it's no more than 4 meters by 5 meters or 5 meters by 5 meters, don't crack our head. You just use 200 by 200. Both the left men and secondary reinforcement. So if you are doing a beam and you see a beam of 4 meters and it's a 3x16 at the bottom. If you see a beam of 3 meters, you do a beam of 5 meters and it's 3x16 at the bottom. When you see a beam of 4 meters, you don't need to go and start scratching your head again. You just put that 3x. That is the same thing applies here. So node 10 now, we calculate it, also 10 houses. It's also very straight on jacket. Then node 9 now will now be node 12 plus node 10. And that will give you 0.83. Of course, you know the pipe size. I don't need to tell you that one. Then we now move to node 8. Node 8 now, node 7 plus node 9. Node 7 already is 2.1 something. Node 9 is 0.83. Therefore, it is 3 liters per second. And 80 mm is still applicable. All the experienced engineer here will begin to see reason in why nominal pipe design is not bad, but you must be careful. You must nominal pipe design, but not the one I see Nigerian engineers doing. They will just put the whole size, 75 mm, 75 mm. No, it must vary as you move upstream. So node 5 has 15 houses. We calculate 65 mm, no issue. Node 3 has 16 houses. You calculate 75 mm. No issue, just use nominal design, nominal pipe, sorry. Base pipe or benchmark or baseline, sorry. Baseline pipe size. Now looks more complicated. Node 5, your node 4 value. And so let's go. So node 3 is 0.7574, node 5 is 0.69, node 8 is 3.01, and it own few houses attached to it is 0.46. That gives you a total of 5.9 liter per second. So that becomes what it is. So that gives you 100 mm pipe size.
Sorry, can I ask a question?
Now, go ahead. For the first time, the pipe size has increased beyond.
So nominal. We are seeing the dummy. We are seeing the dummy in between 2336. Now, I'm not seeing the direction where it's flowing. Is there any way we need to know the direction? Which one is supplying?
Okay. Just like I said. So, like I said now, you remove those dummies. For now, we are doing branch system design. We said that those dummy comes in when you are doing loop design. I also said something that the dummies are there because of if you want to route water from another zone. So in this case now, the dummies now, and if you are doing loop design, what you need to do is that you check these two pipes. The bigger of them, you put it there. Instead of doing hard cross, doing all those complex calculations, you don't need them. All you need to do is that if 75 mm is coming here and 100 mm is coming here, I want to loop these two systems, just use the bigger of these two. But for now, we are using the layout we're using is the one on chapter 8 that does not have this dummies. So these trace lines, dotted lines, sorry. So just to move those dotted lines, and that is the design we're doing. I don't know if I can go there, chapter 8. Can you see my screen?
Yes.
Okay. So that is my screen now. That is what it is. So let's continue.
Okay, thank you.
So node 2 now. This is node 2. So if you go to node 2 now, we say 6 houses. So if you multiply 6 houses by 0.046, it will give you 0.28. So node 1 now becomes node 2 plus node 4. Because there's nothing connected to node 1. Do you remember? There's nothing connected to node 1. So the water demand for node 1 becomes 0. So by the time you add it up, you get 5.18. Did you get it now? So the pipe size for 5.18 becomes 125 mm. And the velocity at that point is 0.6 meter per second. Now, do you notice that? The one I gave us for 30 houses, we got 7. and the thing was 150 mm, right? Now, the one I now say, if there are 20 houses now, 20 persons per house now, it becomes 125. So the nominal pipe size now is now 125. Did you get it? So the velocity at that point is 0.6 meter per second. So if you calculate all these things, this is the value you get. Now, another thing to learn here is that now that we got this now, that means the main pipe from this tank is 125 mm. .18 liter per second is the pipe size. I can use this to have an idea of the tank size I need at that point. By converting this back to meter cube per day, and when I convert it to meter cube per day, I will get 447 meter cube per day. So this is the size of tank that I need to service that number of persons, of 20 people a house and 100 houses. So that is technically 2,000 population equivalent. So it means that for me to service 2,000 population equivalent, I need about 447 meter cube per day. Then this 447 per day, because I expect that I'll be pumping 2 times per day, I'll divide it by 2. Otherwise, I'm pumping every 12 hours. So the actual tank size I need now is 220. If I'm pumping 4 times per day, I can divide it by 4 again. That means every 6 hours I'll pump water. But then, gentlemen, we know that pumping water twice per day is just optimal. So this is the size of tank I know. So if I'm now asked to design this tank and say, what would be the dimension of this tank? All of us did mathematics, all engineers. I would say, if it's the rectangular tank, for instance, I would say a tank is length times breadth times height. I will first of all assume that the length is twice the breadth. I will assume that the length is twice the breadth. To achieve that, I will now say L equals to 2B. And I will now fix the height. All of us know you can fix the height of the tank based on the dimension of the sheet you're using, or the applicable formwork, or whatever parameter you use. You can just fix the height. Okay, I want my height to be 4 meters. I want my height to be 3 meters. I want my height of my tank to be 10 meters, whatever. So I'll fix 2 parameters. Therefore, this length times breadth times height will now become 2B times B times 5. 2B is now L, B remains B, H becomes 5, equal to this. Therefore, if I do my mathematics, I'm going to get my B to be 5. Therefore, L is automatically 10. The other one is 5. So I'm going to construct a tank of 5 meter by 10 meter by 5 meter. That is the nominal tank design based on two period pumping. But there's something you need to add. There's what we call fire requirement, firefighting requirement. And then there's what we call equalizing volume. Equalizing volume, you need to add, emergency volume. This value, when I got this value, I need to add 2 extra parameters. There are 3 parameters that make up the overall parameter of a tank. It is in your test. You must add the, you must add 2 other parameters. And those other parameters are the equalizing emergency volume, which is about 20%. In other words, if you get your pipe size to be 100 cubic meter, you just assume 120. Let 20 be emergency volume. Emergency volume, that emergency volume could be fire, it could be something, it could be repair, it could be an impromptu party. Come up and Are we okay? Any questions so far? Any questions?
Yes. Yes. I have a question.
Hello.
Yeah, we are here.
Okay, sorry, my network cut me off. So an engineer said you can record so that we'll get that important part.
Okay. So where do I start now?
Please just try to rewind so that you can capture that. This is a design key issue.
Ooh, that would be huge. In every tank design, you estimate the height of your tank. There are two different things now. The height of the tank above level is the height of the stanchion, let's say, or the elevation, or if it's an elevated tank. But in the tank volume itself, the tank volume will have three parameters, except it's a cylindrical tank, which only have a radius and a height. But if it is a rectangular tank, we have the height, the breadth, and the length. We are saying that you can fix the height of the tank, and when you fix the height of the tank, you now assume a lower limit for the tank and upper limit for the tank. Then you now have what we call a design water level. Even when we are doing computer application, the software will ask you, what is the design water level? There must be a design water level. That design water level is a nominal level, which is not the upper, which is not the lower. The lower is what we call dead load, because at this lower level, once the water goes beyond 1 meter or 2 meters, depending on the tank, there will be signal. Signal will go and say water is finishing. So you don't use that as your design. Then when water is exceeding the upper level, the signal will go and say we are exceeding the upper level. So that is why you must use a design water level. So that design water level, you now add it to the height of the stanchion. Let's say the stanchion is 6 meters, and the design water level now is 2.5. You now say 2.5 plus 6 meters. It will now give you 8.5 meters. You get the point? It will now give you 8.5 meters. It is that 8.5 meters that you will now use as your water height of tank, and not using 6 meters or using 11 meters. Okay? 6 meters is the lower, 11 meters is the upper. So you use your nominal, meaning at every point T, I assume that if water is at 8.5, I can balance my system. All right. So now, the next thing we're going to move to now is the computer application. We have 1 hour to do that, but I hope we can meet up. But what we have done so far is quite self-explanatory. All I need to do is to give us some design for the previous stuff that we have done. Now, for the computer application, it will take us some time, but I would like us to go to every software, whether AutoCAD, Civil 3D, or anything, has this interface. So here is called the name bar. This is the name bar. These ones are called the menu bar. So if you click like file menu, it will have other sub-menus. Edit menu, sub-menus, view menu, other sub-menus. This one has other sub-menus. So then this one is called standard toolbar. The standard toolbar has copy, open, save, print, copy, delete, search, execute, query, graph, tables, options. So if you hover around it, one is hovering. This is window operation. After that, you now have what we call toolbars. You have what we call toolbars. In these toolbars, you now have the operation tool, what you now use in working. For instance, this one now is called select bars. This one is called select region. This one is called pan. This one is called zoom in. This one is called full extent. This one is called add junction. This one is to add junction. This one is called add reservoir. This one is called add tank. This one is called add pipe. This one is called add pump. This one is called add valve. This one is called level. So I want you to play around with it. Here is called network map. And this one is called browser. If you see, you can click on it, it's now highlighted. It's called a browser. In the data browser, there are two sub-browsers. There's the one we call data browser, and we have the map browser. The map browser is for viewing results. The data browser is for imputing parameters. So let's say, for instance, I want to impute a junction. I'll go here now, I'll say add. It will say add what? It will pop up this. So it's going to add a junction whose junction ID is 1, J1, whose coordinate is not given, description is not given, elevation is 0, base demand is 0, demand category is 1. So what usually happens is that it is not everything here that you have to fill value for. You fill value for the most important one. And this one that have this not available, it is because you have not done your design. When you finish design, it will now give you actual demand, it will give you total head, it will give you pressure, it will give you quality. Just like we have our chart. You impute 2 values, it will give you 2 values. So in this case, you're going to impute 4 values, it will give you 4 results. That is what it is. So if you look here, you see that this thing is reading J1. So that means I can close it. So it has given me J1. I can click on this, I will delete it. I will say yes. Now, just like every other software, before you start doing anything, you have to go and do what we call project setting. So you come here, you go to default. When you go to default, you now put, these defaults are very important. This is where you specify whether you are doing things on liter per second or you are doing in gallons per minute. This software was designed by Americans, and the Americans use what we call imperial units, meaning that Americans use gallons per minute. Here in Nigeria, we are using SI units, metric system, meaning liter per seconds. So this is where you go to change them. For instance, if you go to the tab shown as hydraulics, you see that flow unit is in GPM. If you click on it, it will open up and show you other units. I can scroll down. You can see liter per minute, liter per seconds. So watch the bottom of here. Now watch the bottom of this page, the bottom here. You see the gallons per minute. Once I go here and I change it to liter per seconds, it will change. When I say okay, here it will ask you what is the hydraulic Hess formula you're using. There are 3 of them. HW is Hessing-Williams, DW is Dashi-Weisbach, CM is Chesi-Manning. These are what head loss formula. You can use any of them. Let's leave it as Hessing-Williams. Specific gravity, we're using water. So the specific gravity of water is 1. Relative viscosity is also 1. Maximum trial, you leave it at 4. So, generally in computer issues, anything that you don't know what it means, you leave it at default. You don't need to kill yourself. Once you see something, you can leave it at default. That is very natural. Okay. Now, if I set all the parameters for this, I'll leave it in where it was before. I'll leave it in gallons per minute because I'm going to give us one exercise to do, or we're going to do next week. Because when I'm seeing it now, we might not really exhaust this computer. So let me do the introduction to the computer interface today. Hopefully by next week. That means I will likely eat up the time for road. Let me take 1 more week to emphasize this, so that when we go to the software for water or stuff, it will not be too difficult. So because it is the same interface. So let me use my time this week and teach us everything about the interface, so you understand, so that when I leave this meeting, you will spend the next 1 hour on your own, try to review what I have done, just to master it, have a mastery of the interface. It's a simple software. It's not difficult. It's free software, but it's very powerful. So let me leave it at gallons per minute, which is what it was before. Then I will go to properties. Under properties, I will set the elevation. I will set my tank diameter. I will set my tank height. These are default values. It does not mean you cannot take it. But you see, those of us who are into design, it is good that you set your default ion size, this size, so that if you miss any one, the computer will automatically adopt the default parameter. In fact, if you're using AutoCAD or any other software, always go and set the default. Are you drawing in units? Are you drawing in meters? Are you drawing in kilometers? Are you using tolerance value of 0.2? Are you using value of this? What are the boundary conditions for designs? You must set them. What are the boundary conditions for design? You must set them. So that when you set them, if the system will assume the default at every point, at every given point. So now if you look at it, because I'm the one using the panels, you could see that I've set my pipe diameter at 75. And I've set my roughness factor at 140 because now I'm using PVC pipe. And how do I get that 140? Just go to Google and say, what is pipe roughness of PVC pipe based on Hazen Williams? You know, as a designer, you must not play with your Google. I know we all know that already. What is pipe roughness coefficient? See, this is giving me the value here, but this is in metric units. So I can put Hazen Williams. Once I put Hazen Williams, you see, I'll click on this. Oh, internet toolbox. You see, this is the material, this is the Hazen Williams coefficient. So where is PVC? Fiber, look at it. Fiberglass, 150. Galvanized glass, 300. Plastics, 130 to 150. Polyethylene, 140. So did you see where I got my 140? This website, Internet Toolbox, is very powerful. Let me copy it and put it in our WhatsApp group. It's very, very powerful. If you're a designer, it must be your friend. If you're a consultant, sorry, Internet Toolbox must. In fact, you don't need to be a chemical engineer. Just go there and look up any system you want to design on, or how to use anything. It will give you there. So let me put it on our group so that we'll not forget it. It's very powerful, and I highly recommend it. Okay, so you can see where I got that from.
That side, PVC is 150. I'm seeing 150.
It's polyethylene. PE is 150. He said plastic. He said 130 to 150.
Down, polyvinyl chloride. Is that not PVC?
I can't see it. Where is it?
It's down. After polyethylene, polyethylene.
Okay, 150. Okay, use 150. Okay, I'll change it to 150. It's okay. All right. So where are we now? I opened this thing twice. So now you said like this one we did, you know, okay, luckily now we have decided our tank height. But now if I'm doing a meter, I'll come here and change it to 5. You get the point? Tank diameter. Remember, it's about 5 again. You know that kind of thing. You just set your parameter. Auto length on, auto length off is important. When auto length is off, if you draw anything, it will automatically capture the pipe size or the pipe length if it is on. If it is off, you have to go back and manually put the pipe size. Please take note of this. That's why you know, you can give me the map of Abuja and ask me to do estimate of the pipe sizes. If I can put it in EPANET, as I'm drawing the pipe from Wuse to here, from this, is capturing the sizes automatically. but I'm going to share the video how to learn how to do it. That is why it's so powerful. You can just quickly use it to get simple parameters very fast. Then I can now go to labels. You see, my own say J, so I say let my labels be J1, J2. I can change it. Let my tank be tank 1, tank 2. Let my reservoir be reserve. Let my pipes B. You can go here and change it and say let my pipe be N or PP. But I say underscore. Why I put underscore is that if I put the next pipe, it will now be P1 underscore or P2. Okay, let's say P. If I say P now, I say pump. Pump, let pump be pump. I click, if I set all these parameters, I set up this property the way I want it, I'll click OK. Then, let me draw something that looks like what we have. I'll first of all draw the nodes. I'll go here, I'll pick up a node. If I pick up a node, this cursor will change. When it changes, it means it's active. I will drop this. I will drop this. So let's say I want to draw this. Let's say this is what I want to draw. So I know how this thing is, and I'll use it on paper and I'll be drawing it. So I will drop this. I'm dropping the nodes. But you can see that the nodes are not bringing me numbers. So what I'll do, I will click on this select so that I stop dropping. Because anyway I drop that thing now, it will drop another node. So I'll click selecting. I'll go to view. I'll go to options. Please, every software has options. Options is where you set your right-click customization, the font of your size, the color of your screen, and everything. Please take note. I'll go to options. When I go to options, you can see that the node size is 3. I'll increase it to 6 so it can be bigger in my eye. The link size is 1. I'll change it to 3. Let me increase the node size to 10 or 8. It's very big. I'll go to label. Nothing to change. I'll go to notation. I will click display node ID, display link ID. So it will display their link IDs. So I can see which one is node 1 and node 2. Then symbol, nothing to change. Arrow, there's no flow arrow. I can say, give me flow arrow. And I increase the size to 10. The background, I'm using white background. I prefer white background. After that, I'll click OK. So have you seen that the thing has increased? And has also introduced J1 and J2 for me. I will now go here and click pipe. I will click on the center. Once you click on the center, it will turn to a pencil. You know that you've gotten it. If I click on the center, I'll remove my hand, my mouse. See, I can move around. Please don't click again until I go to the next center. And I click again. And once I click, the nodes will disappear to a cross, telling me that I've established a section. And it will give me P1. I will go again. I'll click on this one. I'll go to the next node. I will just click once. It will give me P2. If you did not click and exit, you got it wrong. Please take note. So I'll look at this screen again. This is what I want to draw. Okay, so I can see how it is. So I'll go back again. I will pick up the node again. I think okay, so I'll place one node here. 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 Then I'll place one node here. Now I'll zoom out. Sorry. I'll pan. This is panning. I'll go back to node. I'll place one here and I'll place one here. Then I'll use pipe and connect all of them in no particular order. In no particular order. I'm just trying to connect all of them, just to make it look like what we have there. It mustn't look like it. We can see I did something similar. Once you click and click, the thing will disappear. If it does not disappear, then you are wrong. So we have done this now. Now, let me find small. I might wish to remove this, or I just introduce a reservoir. Let me say, so I'm going beyond what we have on the drawing, but just bear with me. So this is a reservoir. I'll now connect here. I'll click at the center. Reservoir, yeah. You see, I tried to click, it wasn't giving me pencil until they finally gave me. Then I know I'm got it right. So I'll click at the center and it will quickly give me. Right? So this might look different from what we have, but it's just to give an idea. So now, if you look here at the data browser, it's telling me pipe. So it's assuming I want to delete any one of them. Let's say I made a mistake on this one. I'll click on it. Either I go here and I click delete, it will delete. Or I come here, I right click on it and I click delete. Or I can also click here, go to my keyboard and click delete. When I finish, I will now come here. I will right click. If I right click on this reservoir, it will give me property. I'll go to the properties and I will change the property. I can input the head. So this one does not have head. I can now come here and put 310 instance. We're not doing the design today because I've seen that time cannot allow us. But I just want to give us an overview of so that when I leave here now, all of us will stay behind for 1 hour. And then I'll give you a video to watch and practice so that by next week, Saturday, it will not be difficult for you. Please, I want to crave your indulgence. Try and watch the video I'm going to send now. That will give you an overview of how to use this software. Let me see that my copy is now to add value. To add value. In fact, within the week, I will make a call and say, please, everybody try and watch it. I'll do a reminder, sorry. So you see, once you press input any value, you press enter. The system will accept it. So I've given this reservoir at 310. So that this is the value. I can if I right click on this one now, there's no elevation. So I'm not going to give it elevation based on those design we have. So what I basically have done now is to show you how to use the whole design, how to use the interface, how to mastery of the interface. Now, this is the data browser. When I finish my results, that's when I'll go to map browser. Now there are mistakes, simple mistakes that people do. Sometimes there's something you click and this thing will disappear. That place is window. If you go to window now, you discover that map browser is clicked on, data browser is clicked on. If you mistakenly click browser again, bam, it will disappear. Okay, when it appears, you go back to file, you go to legend, two bars. See the map bar is there. If you want any map to disappear, you can come here. If you click map, something has disappeared. You go back again, you click it again, it will come back. The same thing with my browser. If I click on my browser now, it will go off. If I click on it, it will come on again. And so on and so forth under view. So once again, you go to options, you set up the options. If the size is too big, you go here, reduce it to 6. What again? What else? So here, I can click here. I'll check all my junctions. I have about 13 junctions. If I go here, I can click my reservoir. I have only one reservoir. If I go here, I click my tanks. I don't have any tank yet. If I click here, I go to my pipes. I have about 13 pipes. So it's either you work here or if I click here now, if I want to edit pipe 10, for instance, I'll click on it. I'll click this one, edit. You see, it has captured some of the default values for me. Roughness factor 140, diameter 25, pipe length 10. It's me that impute. These are the things I impute. So I can come here now. I can change the pipe length here now to 100. The system will see it as 100 meters, depending on the unit I'm using.
Sir, but you change the roughness factor as 150.
Yeah, but if you change it here, the best thing is to change that the default so that you affect all of them. If you change it here at 150, only this pipe 10 is affected. So will I now go and start changing all of them? No. What I will do is I'll go to default. I'll go to hydraulics and come here. Okay, no, property, sorry. 150. So all of them will now be affected. I say, okay. So if I click on this one, oh no, this is a node. This is a node. Okay, still saying 40, but I know where to change it. Before I run it, I'll go to yeah, I'll go to default, I'll change it before I run it. I'll say save for all new products, all new ones. So if I draw a new pipe now, from here to here, and then I go and click select, and I double click it, it's now 150. Please, there's a mistake people also do. Anytime you finish using one toolbar, go back and click on this black one, so that your mouse will be free. Because if you click here, once you click on that place, it will drop another one. So the best thing to do is to go back and then click this thing. And another thing about this software that does not have undo or delete. It has existed for 30 years. So you can imagine that. Okay. Any question? Any question? Please, time to ask question.
Sir, please, I think I want to ask a question. Maybe I wasn't in the first class, but I dropped a comment in the WhatsApp.
I expect many of us to be asking questions on the WhatsApp group to be answered.
Concerning the nomograph, you were saying that is a German analyzed.
There are many charts.
So I
online.
my question is, in Nigeria, don't we have our own nomograph?
We have.
Then
we have.
Okay.
Yes, if you use it, you get the same value.
Where can we get access to it? How can I get it?
Google it online.
Okay.
Because there are many charts online. No, we are using British standard.
Yeah.
So
that's number one. Then number 2 is this EPANET. Is it the only software we can use to design our pipes?
There are many. There's WaterCard, but this is the one I know how to use.
Okay. Okay. Do you have any idea about HI8? It's a software.
Yeah, it's not for pipe, it's for cover design.
Okay.
That organization, US Federal Highway, US Highway, I don't understand the last word. They also have another chart. That one I will introduce it during our. The why that one is difficult for me to use is that it's in inches. That's all.
Okay, sir. Thank you.
Anything US is Imperial. Are you with me? So now I'm going to share a video on what we're doing next week. I'm sharing on the group. I'm sharing on our network now. Please, it is 48 minutes. So we're going to close the class now because of our rules. But I want you to sit back, unless you're going for a program. Sit back and watch this 48 minutes video. You will learn a lot from it. You will learn so much. Sit back and watch this 48 minutes video. I cannot keep everybody here because people have their program. People have program that they have a training by 12 o'clock. Please, sit back and watch this 48 minutes video. And then another 40 minutes video. So watch one that's first of all 48 minutes. And then watch another one that's 40 minutes. So I'm posting 2 videos. You can watch one now. You watch the other one later on. Please. So I will try and see what we'll do next week. Let me see how this, because we're supposed to be done with this course, but I can see that many of us might have challenges. So next week, I will just spend 1 hour, 30 minutes and then brush us through. But please, watch these videos. Watch this video to make it easy for everybody. Because you know it's computer class, right? It's a computer class. And everybody might not really follow up very well. Everybody might not really follow very, very well. So some of us are not very good in computer. There's no gainsaying the facts. So the best thing you can do for yourself, in order not to draw others back, is please just find time. Watch these videos. It's in our group. I've posted it here now. So click it now. Let it come up. Let it come up on your screen. So while I drop this class now, you continue with it. One is 48 minutes. One is 40 minutes. First of all, start the one with 48 minutes. How to digitize, how to use the panels to model a water system. It's so cool. So any other question? So once again, we'll come to the end of our class today. I have to say thank you for everyone. I know it's not easy to leave your busy schedule and come for training, but I believe that value has been added. And by the time we are following this training, all you need is now the discipline to practice and go through all that you have learned. And I can tell you, you will learn a lot. Thank you. I'll end the meeting for now. Please let the discussion continue on the WhatsApp group. I have not been seeing comments. Maybe all of you are not are following, sorry. But please, if there's anything you're not following, chat me on WhatsApp. I don't even know how to reply you. I've seen people who share experiences with us here. I will end the class now. I crave your indulgence. Make your comment. Let us. You are taking the discussion to the WhatsApp, sir. Well, let's end here. Or, let me end the video. Okay.